This is a Model 25 water meter, the kind you'd find across the country and even around the world. And Badger Meter makes over 1 million of these every year. It seems pretty simple, a brass body, a plastic register, but there's a great deal of workmanship and engineering that goes into making this into a high precision flow measurement device. This meter takes an incredible journey from raw material to finished goods. I think you'd be amazed to see this process. So come with me and let's take a look. It all starts here at the receiving dock of H. Kramer & Company on the south side of Chicago. They collect scrap brass from all over, copper, tin, zinc, and they melt it down to make this the most recognizable part of our water meter, the brass body. You can see what they've got here. They melt down old candlesticks, water meters, car radiators, even musical instruments, all to make this water meter. That furnace behind me is running at 2,200 degrees, melting all of the scrap and pouring it into the individual molds that will make the brass ingots. So that's it. We now have a finished ingot, which gets put into a pallet, shipped off to Fall River Foundry for the next step in the process. Now we're in Fall River, Wisconsin at the Fall River Foundry, where the brass ingot made by Kramer gets turned into a finished water meter casting. And it all starts in this 2,500 degree furnace. Since drinking water will be running through our meters, we need a very exact percentage of these metals. So Fall River mixes up our custom recipe for brass. When the mixture is just right, it's time to transfer the molten brass to another furnace so it can be poured into molds made of tightly packed silica sand. The molds have a top, a bottom, and a spacer that represents the hollow core of the meter. The molten brass will flow into the hollow cavity and around the spacer, forming our meter. After they've cooled, those molds go through a machine that breaks up the silica sand and reveals a very rough casting of our brass body. After a little bit of cleanup, they're ready for the next step. So that's the process at Fall River Foundry. We now have a finished casting that's heading to Milwaukee for machining. And now we're on the south side of Milwaukee at Fall River Manufacturing, where in a highly automated process, they'll take this rough casting and turn it into a finished machine casting ready to be made into a water meter. Each of these machines has a specific job, from machining the surface for the actual register to threading the ends. They drill and tap for the bottom bolts and even perform a leak test to ensure they are 100% defect-free. This finished casting is ready to have the critical measuring element installed. Let's go up to Milwaukee and see how those measuring elements are made. This assembly is what makes our meters the most accurate and dependable meters in the market. I know it looks simple, but this disc and housing are built to unbelievably precise specifications. So how does it work? Well, as water runs through the meter, the disc nutates. Yes, I said nutates. It is a word. Essentially, the water flowing through the meter makes the disc spin. The disc turns a magnet housed inside the brass body. Another magnet is located inside the register. That magnet is a polar opposite, so as the magnet inside the brass body turns, so does the magnet inside the register. This allows the meter to measure the flow of water. The next part of our story starts here in Nogales, Mexico, where the water meters are assembled and tested. Registers like this are also manufactured here, as well as the radios that transmit the flow data. Eventually, all of these components are assembled into the finished water meter. Here in Nogales, there are three key functions. One is to assemble the critical measuring element, place it inside the meter, close it up, and check its accuracy with a flow test. Second, in the injection molding area, we produce the plastic gears and other components that are assembled into the water meter register. We also manufacture the plastic housing that contains the radio that transmits the flow data. One interesting thing in this area is that we manufacture plastic meter bodies, identical to our brass meter bodies, but made from a high-performance polymer for a very cost-effective solution that many of our customers prefer. Once all the pieces have been molded, we're ready for assembly. These ladies carefully place the gears into each register, along with the familiar number wheel. When the process is completed, the components are assembled, and voila, we have a finished water meter. And from here, these meters are shipped to municipalities all over the world. And now the completed meter is ready to be installed in a house by Hank here, where it will accurately and reliably measure water for the next 20 years. So Hank, what are you going to do for the next 20 years? So now that the meter has been installed in the house, the utility can begin to collect data from it. This particular meter has a radio on it that allows the utility to collect the data while driving down the street in a vehicle like this. Other meters have radios that allow the utility to use a fixed network system. But regardless of the type of radio, this automated meter reading system provides a very efficient way for the utility to get its data on an accurate and reliable basis. So that's the story of the Model 25 water meter. It's taken an incredible journey from skids of scrap to a finished meter. And it's amazing how many locations and hands were involved in making this a Badger meter.